Okay, let's review Newton's laws for your test on Wednesday. So the things I'm going to say on this video are the things you need to know for your test. Hint, hint, pay attention, watch this more than once. So the first law is Newton's law of inertia. You need to know what the word inertia means. It was in your slides on Friday, 2 Fridays ago. It's been a long time for y'all. So inertia is the tendency of an object to keep doing what it's doing. Newton's first law has been called the law of laziness because it's kind of a joke, but objects that are at rest, they want to stay at rest. That's what inertia means. Objects are going to keep doing what they're doing. So the law says an object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. So an object at rest does what? Stays at rest. An object in motion does what? Stays in motion unless acted on by an unbalanced force. You should be able to say that. So that means if anything is just sitting on the table, my water bottle is just sitting here, it is going to stay at rest unless acted on by an unbalanced force, meaning that if it's at rest, the forces on it are balanced. So that's really important. So you need to know that if an object is at rest, that means the forces are balanced. Or I should have said at rest or moving at a constant speed. The forces are balanced. You know what? That is so important that we're going to add that right now. So a car moving exactly 20 miles per hour and not changing is also an object that is balanced. So if the object's at rest, the forces are balanced. If the object is accelerating, speeding up, slowing down, changing directions. But know those 3 forms of acceleration: speed up, slow down, change directions. The forces are not balanced. So water bottle sitting on my desk, the forces are balanced. I pick up the water bottle, that means the water bottle accelerates. Forces are unbalanced because I picked it up. I applied a force to the water bottle. All right, so as far as test goes, examples like this may have, or test questions over this may say things like, what would happen if? So if you are driving in a car and you have your purse in the front seat, girls, one day you'll experience this. Guys, it'll be your, I don't know, your backpack, your football, your something. But anyways, groceries, something. You have it in the front seat and you have to kind of slam on your brakes a little bit. Your car stops. Your car is an object in motion, you're driving, and it stays in motion until an unbalanced force stops it. The brakes are the unbalanced force. So your car stops, but your purse next to you is also in motion. So even though your car brakes, your purse stays in motion. Just like you stay in motion, you go forward, your purse goes forward until an unbalanced force acts on it. What unbalanced force stops you? Your seatbelt. What unbalanced force stops your purse? Unfortunately, the floor. And a lot of times it's the floor with all your stuff spilled everywhere. So annoying. You can seat belt your purse in though. It's just a little life tip. So in this GIF, which we talked about in your warm-up a while back, but you see that the car is in motion and then it stops because it runs into something. But after the car stops moving forward, the person continues to move forward. So car stops moving forward, person goes forward through the windshield because the person was in motion, so they stay in motion. All right, Newton's second law, the law of force and acceleration. The acceleration of an object depends on the mass of the object and the amount of force applied. So this one is normally really common sense because you can think about it and you can come to the answer, but you have to choose to stop and think about it. So what I mean is if we have, let's say we have an 18-wheeler and we have a Corvette. Let's pretend they have the exact same engines. Some of y'all know that that's not true. Let's pretend that 18-wheeler and the Corvette have the same engines and they take off from the same starting point. Which car will accelerate faster? Y'all know that 18-wheeler is going to accelerate slow, so the Corvette is going to accelerate faster, but why? Why? The Corvette's mass is less, so it takes less force to accelerate it. If these two cars have the same force applied, the Corvette has a smaller mass, so therefore it can accelerate faster. If you're at the grocery store and you have a shopping cart, and that shopping cart is piled high, all the way to the top. Somebody got some money today because it's piled to the top. And you apply a force, okay, so your shopping cart might go a little ways. But if that shopping cart was totally empty and you applied the exact same force, that shopping cart is going to roll down the aisle. So the more mass you have, the less acceleration if the same force is applied. So you need to be able to say, okay, if the masses are the same and the forces are different, how will acceleration be affected? So if two objects have the same mass, but a different amount of force is applied, the object that has more force applied will accelerate more. You need to be able to say these things. So let's watch this example. I've probably watched this 100 times. So they head towards each other at about, same rate. But who has a greater acceleration, a greater speed up, slow down, change directions, the girl or the guy? Definitely the girl. The girl goes flying. Why does she have a greater acceleration? She has less mass, which means he has more mass. He applied a greater force. Okay. Talk about Newton's third law, the law of action-reaction. So this law says for every action, there is an equal but opposite reaction. When we're talking about this law, it's really important to remember that forces occur in pairs. They occur in pairs. And force pairs occur on the same object. So, watch Bart. So if we are talking about the fire extinguisher and Bart, the fire extinguisher applies a force forward. It releases something to go forward, which applies a force backwards on Bart. That's why Bart moves backwards. So the fire extinguisher applies a force forward, which applies a backward force on Bart. When you were talking about this, so let's just do a really easy example because that one's too easy. Let's do like a simple example. If you were standing on the floor, you are applying a downward force of gravity on the floor. So there has to be, forces are in pairs. So what is the other force? What is the reaction? You apply a force down on the floor. What's the reaction? The reaction has to be opposite. So the reaction has to be up because you're applying a force down. It has to be equal in strength. And it has to be on the same two objects, you and the floor. So if you apply a force down on the floor applies a force up on you. The action, the reaction have to be on the same two objects. So if you're going to go play tennis, you swing a tennis racket. The racket applies a force on the tennis ball. I have a tennis ball, but I have no racket, so we can pretend. The racket applies a force on the tennis ball. The tennis ball applies a force back on the racket. It has to be the same two objects. So how do you find that out? You know that the racket applied a forward force on the ball. The other force has to be opposite in direction. So that would be back on the racket. and has to have the same strength. So the ball has to apply the same force back on the racket. You swing a golf club. The golf club applies a forward force on the golf ball. Golf ball applies a force back on the golf club. Same two objects, opposite directions. That is very important. Okay, remember you have a test on Wednesday over this material. You got it.